Today I will start the new chapter, that is mechanical properties of solids. Okay, when a rubber band is taken, that rubber band is stretched, its length is increases and its area of cross section is decreases. It means what? Its shape is changes when applies the force, and that body is deformed. Therefore, that applied force is called as the deforming force. Deforming, that is the force. When remove the your deforming force, then that rubber band comes to its original condition. Therefore, that is called as the elastic bodies. That body has the special property. That body has the special property when that is the deforming force is applied, then that body has the deforming, when deforming force is remove it, then it comes to original condition. So such property is called as the, that is the elasticity. Therefore, that is the elasticity, the special property of a body by virtue of which it regains its original condition after removal of, that is the deforming force. That is called as the elasticity. That is called as the what? That is the elasticity. The example for the elastic bodies, your rubber band, copper, iron are the examples for the elastic body. The elastic body, it means what? A body has a special property by virtue of which it regains after removing the deforming force. Such body is called as the elastic body. That is called as the elastic body. Clear? And the next one is the what? It is the perfectly elastic body. The next one is the perfectly elastic body. It means what? A body has a particular property. A body has a particular property. It regains its original condition completely after removing of the deforming force. Such bodies are called as the perfectly elastic bodies. Perfectly elastic, that is the bodies. Clear? And the next one, the plastic bodies. The plastic body. Plastic body. Clear? When a body can't regain its original condition, a body can't regain its original condition after removal of deforming force. That is called as the, such body is called as the plastic body. And that plastic body is, that is the mud ball. That is the mud ball. That is the mud ball. And this is the example for the plastic body. And the next one, this is the plastic body, perfectly elastic body, and the elastic body, elasticity. See this one, that is, now we go to the next one, that is the here the atom is considered, or that is the solid is taken. Solid is consists of the number of atoms. That atom that is the surrounding by the number of atoms and connected by the what is the and these two atoms are that is the connected, that is by the interatomic distance. This is called as the interatomic, that is the distance. Clear? That is called as the interatomic, that is the distance. Like that. When that is the applied the force on this solid, then what happens? This is that is the compressed heat. That is the compressed heat. That energy, that is the your applied energy is stored in this, that is the distance, or in this one after removing of the applied force, that is comes to its original condition. So this is that is the your elastic behavior of the water is the solid, and that energy is stored, that that is the energy is stored in the between these two atoms. This is just like as an a, that is the spring in between these two atoms, that is act as a, that is the spring. Clear? When that is the the restoring force is set up inside the body per unit area, that is called as the stress. See this one, that is the stress. Restoring force, that is the restoring force is set up. The restoring force is set up inside the body per unit area, that is called as the stress. Therefore, the stress is equal to, that is the restoring force divided by area. And the force is measured in Newton, area is measured in meter square. Therefore, unit of the stress is Newton per meter square. Clear? And the next one, that is the types of stress. That is the types of stress. That is the types of, that is the stress. Clear? The first one is the tensile stress. The first one is the tensile stress. Tensile stress. Second one is the shearing stress. Second one is the shearing stress. And third one is the volume stress, or another name is bulk stress. Volume stress. When that is the force is applied, force is applied to the body, then its length is increases. Its length is increases. Your force is act on the body perpendicular to the act on the body, then its length is increases. Such stress is called as the tensile stress. For example, here one rubber wire is taken, applied the water to the your force perpendicular to that one, its length is increases or changing its length. Such stress is called as the tensile stress. And the second one is the shearing stress. When the force is act on the body, then its area of cross section is changes. Such stress is called as the shearing stress. And the volume stress, the force is acting or deforming force is acting on the body, its volume is increases or its volume is changes. Such stress is called as the volume stress. Okay, that is the see, that is the first one is elasticity, elastic body, perfectly elastic body, plastic body, and the stress and the types of, that is the stress. Now we go to the what is the next one is the what is the strain. The strain, that is the strain, it means what? Strain, the ratio of the change in the dimension to the original dimension. That is the ratio of the change in the dimension. Change in dimension. The ratio of change in dimension to the original dimension. To the original dimension. This is the what is the unitless quantity. Strain is a unitless quantity. The strain, it means what? The ratio of change in dimension to the original dimension. Okay, that is the next one is the types of strain. Types of strain. Type of strain. First is the longitudinal strain. Longitudinal, that is the strain. Longitudinal strain. The longitudinal strain, it means what? The ratio of change in length to the original length. See this one, delta L. The ratio of change in the length divided by original, that is the length. This is longitudinal strain. Second one is the shearing strain. Second one is the shearing strain. Shearing strain. The ratio of change in area to the original area. For example, see this one. Initially, this is the what the original size of the body is like. So that is the next one here. Okay. This is the length of the body, L. So this is the making an angle theta. And this is delta x. Delta x. The shearing strain tan theta is equal to delta x divided by L. So theta is very small, then theta is equal to delta x divided by that is L. Okay, this is the shearing, that is the strain. The next one is the what is the your third one is the volume strain. That is the volume strain, or in other words bulk strain. Volume strain. The ratio of change in the volume to the original, that is the value. Like that, these are the types of, that is the strain. First one is the longitudinal strain, second one is the shearing strain, third one is the volume strain. Clear? And you know the types of, that is strain, types of, that is the stress. And these are types of strain and the types of stress, that is the related with each other. That relation is firstly given by the scientist Robert Hooke's. Therefore, that law is called as the Hooke's law. That law is called as the Hooke's law, and that is the Hooke's law. That is the Hooke's law. We call it as the Hooke's law. Say this one. That is the Hooke's law. Before we go into that is the Hooke's law, here one rubber wire is there. The force is applied to that rubber wire. Then what happens? It goes on, its length is increases. Again and again, the force is external force is applied to that one. Then what happens? That wire lost its elastic property. Then what happens again and again? Your applied force is increases. Then what happens? This rubber wire is break down, or this rubber wire is cut. This rubber wire is cut into two parts. So up to what? Up to that is the your that is the this wire has the elastic limit or elastic property. That is the up to what that is the that body has the elastic property. Until that loss of the elastic property, that is the stress is directly proportional to that is the strain. So that is the within the elastic limit. Within the elastic limit, within the elastic limit, stress is directly proportional to stay within the elastic limit. Stress is directly proportional to strain. That is the strain. This is the Hooke's law, and so many times that is asked in 1 mark question. State the Hooke's law. Okay, within the elastic limit, stress is directly proportional to strain. The stress is, we write like that, stress is directly proportional to that is the strain. Then removing the proportionality is equal to sign is taken. Stress is equal to K into strain, where K is the proportionality constant. That proportionality constant is called as the modulus of elasticity. Stress y, that is the strain. That is the K is equal to that is the stress divided by that is the strain. Clear? Now that is the, see this one, stress by strain is constant. That constant is called as the modulus of elasticity. Stress has the unit and the strain has no unit. Therefore, modulus of elasticity has the same unit of stress, that is Newton per meter square. Modulus of, where K is called as the proportionality constant. That proportionality constant is called as the modulus of elasticity. Clear? So this is that is the modulus of elasticity. Types of, that is the types of modulus of elasticity. First one is the Young's modulus of elasticity. Young's modulus of elasticity. Young's modulus of elasticity. Second one is the sharing modulus of elasticity. Sharing modulus of elasticity. Third one is the bulk modulus of elasticity. Third one is the bulk modulus of elasticity. So, first one is the Young's modulus of elasticity, that is represented by Y. Y is equal to, that is the, your the the Young's modulus of elasticity, that is represented by Y, that is the longitudinal stress to the longitudinal strain. That is the longitudinal 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 stress to the longitudinal strain. Longitudinal strain. Young's modulus of elasticity is longitudinal stress to the longitudinal strain. See this one, y is equal to, that is your longitudinal stress is F divided by A. Longitudinal stress, that is delta L divided by L. Therefore, that is y is equal to F into L divided by delta L into delta L into A. So, suppose wire is taken, F into L divided by delta L into A is yr square. Wire is taken, where r is the radius of the wire. Clear? So this is the Young's modulus of elasticity. That formula is F into L divided by delta L into yr square. So where F is the force, L is the length, and delta L is the change in the length. Change in the length, it means what? That is LF minus Li. That is the final length of the wire minus initial length of the wire. And the next one is the what? That is the your, that is the shearing stress. That is shearing modulus of, that is the elasticity. Shearing modulus of, that is the elasticity. That is the shearing modulus of elasticity is the ratio of the, that is the ratio of the what? That is the your the shearing stress to the shearing strain, that is called as the shearing modulus of elasticity, and the bulk modulus of, that is the elasticity, the ratio of the volume stress to the volume strain, that is called as the bulk modulus of elasticity. Okay, then that is the continuing in the next class.